as we move along. Now let us understand the kind of application range that you can do with induction heating. So here are a few examples. So hardening is one of them, whether it's case hardening, through hardening, you can do hardening with induction. You can do annealing with induction, bright, black, wire annealing. You would have normalizing. If you wanted to take the material to a temperature just below Curie point and hold it there so that whatever stresses were there were relieved. Then you could do stress relieving, you could do pan bottom brazing. So all the vessels that you use right now, any utensil is also annealed so that it can be given a shape without cracking. Um, you can see pan bottom brazing is used for all the pressure cookers that you use. They are either impact bonded or pan bottom brazed. So there is a sandwich brazing between the inner vessel that on which you put the food, and on the base which goes on top of your stove or on your induction cooktop, a flat layer which is brazed in between both of them is a layer of brass and alloys which form a permanent bond between the two layers. That's pan bottom brazing or impact bonding. Then you have resin bonding. So every time you use pipes or oil and gas pipelines which are going underground are needed to be coated with a layer. If you see that black layer, that's resin bonding. Then there is sintering for diamond tools. You have to do forging for all your automobile components, for your nut bolt heads, various items that are forged. Induction is used to preheat to the temperature. So here's a billet, completely red hot. And you can get induction heaters to the capabilities of 2000 kilowatt and 3000 kilowatts, which can heat a 125 RCS billet block within seconds to 1200 degrees. Yes, that's the speed that induction can have and the consistency. Brazing, again, if you look at here, this is a banjo brazing. Then you have your fuel tanks brazed. I think your diamond cutting tools, drilling tools, they are all, drill bits are all brazed with induction. You have partial heating. So if you had torsion bars and heads that you wanted to give shape to, partial heating, soldering of connectors, conductors, metal melting. So most of the metal today is produced by melting using induction. You have also precious metal like gold. Gold alloying is also done through induction. String fitting. So we'll see a couple of examples of string fitting also. But string fitting, all your motor to stator casings, your compressor, stator to rotor string fittings. Then you have bigger bearings that you want to put into the bearing housing. Those kind of string fittings can be done with induction. Pre-weld, post-weld heat treatment is what we'll be talking a little more about as we go along. Some of the features that you are not very clear, that they are induction, but I'll show you how. So this is one example is induction cap sealing. So if you've been taking any medicines, any nutraceuticals, if you look at your lube oil, your lubricants, your food packing, Bonvitas, Horlicks, anything that you open that has an aluminum foil on it, this has been sealed with induction to a large extent. And in induction, what happens is it's an indirect heating. We heat the aluminum foil through under a tunnel, and when it gets heated, it melts the wax on top of the foil and releases itself from the board that is holding it. And because it's pressed firmly against the bottle, the soft poly layer below the aluminum forms a hermetic seal here. Again, induction speeds here can be as high as 300 bottles a minute. You can look at something like a carbon water filter cartridge, which is there in your water purifiers, whether it's RO or whatever you look at. Now, this is a carbon filter, but on top and bottom, they need to put the plastic caps. Now, how do you put a plastic cap and let it stick there? So they have to do a hot melt glue over here. Again, how do you put a glue and put this up with the speeds of production that you're looking at, maybe 120, 200 candles a minute? It's very difficult to do it with general process. Through induction, we put a small washer here on top with a preset glue ring, put the assembly in place and just let it go under a conveyor on top below the induction coil. The induction coil will only heat the metallic washer. The washer has got perforations in it. It melts the glue and forms a bond over there on the fly. If you've ever been to a hospital or taken an injection, you've been using a catheter tube. This catheter tube has a specialty that at the tip of it is shaped on both sides, inside and outside. Now, how do you give it a shape? Because plastic melts pretty fast. You take a mold which is made out of graphite, and in the mold, you take a syringe on top of this plastic and they push it inside the graphite mold. We heat the graphite, it indirectly heats the catheter tube and gives the shape it wants. Again, very precise operations used in medical fields as well. To give you another two very different examples, one of the classic ones is Mahindra and Mahindra Kandivali team. They were using, when they make the Jeeps, the spot welds that come onto the bonnet have dents. Now to fill up those dents, you need to use solder. So how do you solder on top of a finished good? You will have to heat a sort of a hammer, put it in place and melt the solder there. Now, heating that hammer on the shop floor, you would need gas. And that gas all the time being on a production line poses an health and safety risk. A lot of precautions need to be taken. By switching over to induction, they could simply put the hammer in, turn the button on when the car is approaching. Within a couple of seconds, the hammer gets hot. Use the hammer to do the soldering, put it back in its place. Absolutely safe mechanism. Nobody gets any risks. Removes the sole from shoes. One of the weirdest examples I have seen, and this is how far the application of induction technology is. It's limited only to your thought process. In Iran, when they were making shoes in a particular company, the rejects that were going out of the line, they needed to remove the sole and keep the top shoe intact. Now, to remove the sole, which has already been glued, it was very difficult to pull out the rubber and time consuming. They put an induction heater, which would indirectly heat the nails or which were hammered into the shoe. And once those nails get heated up, the rubber would give way and come off much easily. So this is as far as you can, think about applications for induction. In modern times, you have also seen induction cooktops used in all applications. Now, before I move on to the comparison, I will just pause a bit and take a few questions. Right, I see a lot of questions here. Mr. Rajan Kumar has asked a question that during case hardening, whether frequency would be high or low. Kindly explain. During case hardening, the frequency will be very high, sir, because it depends on the case depth that you want to achieve. And it would be higher to give you, the lower the case depth you want, the higher the frequency. So if you are case hardening a shaft, for example, and you wanted a case depth of only 0.6, 0.8 or under 1 mm, your frequencies would be upward of 200 or 150 kilohertz. And if you are doing say 4 mm, 5 mm thickness case hardening, then your frequency could be medium or low. I hope I've answered that. Kaushal Kishore sir is asking why lower frequency results in shallow case depth. That's because the magnetic field penetrates further inside the job and allows you more deeper heating rather than shallow heating. Okay. Sir wants to know construction of an induction furnace for melting iron ore. Maybe this I'll take it offline. And it's a pretty much a standard thing available anywhere. It's basically when they are melting, especially the idea here is there is one critical thing that they do in melting of precious metals, and when they do melting of metal, when you want to do alloying, you have to do stirring of the molten metal. Now, to do stirring of the molten metal, it's very important that you do it in the right way. Otherwise, the alloys don't mix because they all have different viscosities. The stirring can be done through electromagnetic exchange. So by pulsating the frequency or pulsating the power, you could have an churning effect in a molten metal. That's also used very heavily in the melting of iron ore, and it's also used in gold alloying. We have Mr. Deshmukh asking, for Sandeep Deshmukh ji asking, how can we use this technology for thermal simulator for high temperature cyclic heating and cooling applications of heavy duty brakes. You can share me the details of what you want to do. We can study it and come back to you on the same, sir. How can we use this control during fabrication pre-post? Is there, Sidhuji, if you can stay around for another 15-20 minutes, the rest of the applications discussed in detail are on pre-post heating only. There is a machine available for that, and we'll share the details on the same. Yes, temperatures about 900 degrees can be achieved very comfortably. We will take the next slide on comparison between resistance and induction. Elaborating pre and post heat will happen soon, sir, just after this. One, Mr. Shrikant Nigade is asking, what is the best temperature uniformity that can be achieved across part surface when exposed to induction heating? When I share a couple of slides further down, I will show you that over a length of 12 meters on a 25 mm thick pipe from inside to outside, all across the length, the variation is under 10 degrees. Okay, so that's the kind of uniformity you can achieve. If you had a smaller job, it would be much more uniform. You could have much lower delta T. Mr. Nitin Matre will share details about impact bonding to you by email. Do we do preheat to LAS is safer manner than lesser time? We will discuss in the next. Yes, you can do preheat in low alloy steel as well, sir. Especially in P91 and all, as we move along, we'll know it's something that's more or less mandatory. For non-conductive materials like plastics and rubber, you will have to use an indirect heating method that, as I shared, we did the cathode ray tube by heating a graphite mold. Or you melt, say for example, you are melting something else, you have to do indirect heating. Same machine cannot produce two frequencies. There are different sets. So each equipment will have a range of frequencies that it can operate within. Is there any way for heating non-magnetic material using induction heating? Tamirji, yes, you can use, as long as it's a conductive material. It has to be electrically conductive. Okay. Frequency and power will do the rest. During case hardening, if you wanted to measure the temperature, sir, you'll have to use optical pyrometers and things like that to give you your actual reading. Lovesh ji is asking, can we increase the case depth of an already hardened part? If you have earlier hardened at a lower case depth, and if you redo the entire process, then you can, but you might have to check the metallurgy on the other side. Vasuki ji, cost of stress relieving, we will discuss further down on larger jobs. Again, induction is more of a localized heating, as I shared. So if you were to stress relieve a particular part or a particular length on the entire job, that would be much easier to do with induction. However, if you had a large job, say a 6 meter big job, and you wanted to do the stress relieving of the whole job, then it's better to do it in a furnace, because anyways the post heating or stress relieving will happen at a fixed speed. That means the rate of heating is predefined. In those cases, the traditional furnaces would be better, or much large jobs, as you shared, 6 meter dia and above for the whole job. Yes, that would be the case.